Hi student, welcome you to Sinal's family and congratulations for clearing your boards, and now you have entered into 11th standard. You must have learned a lot of things in your school. So let us see some glimpses of the things what you have done it with respect to chemistry. Now the basic chemistry starts with periodic table, the arrangement of the elements in the periodic table. Now if you must have seen the periodic table consists of 4 blocks. Your periodic table consists of 4 blocks. They are S block element, P block, D block and F block. S, P, D and F. S stands for spherical, P stands for principal, D stands for diffuse, F stands for fundamental. Now the question is, what is the importance of this S, P, D and F? How is the elements arranged in it? You know, the elements arranged in it is according to electronic configuration. Electronic configuration. Now this electronic configuration, which you must have learned in your schools. For example, if I take sodium having atomic mass number 23 and atomic number 11. Atomic number is given by the symbol Z, which is nothing else but proton or electron. Total number of proton or total number of electron is called atomic number. And A is the symbol for mass number, atomic mass number, which is nothing else but a combination of proton and neutron. Okay, so A will be equal to Z minus N, where A is the atomic mass number, Z is the atomic number and N is the number of neutron. By using this formula, you can calculate the number of neutrons. Fine. Now, if I ask you to write the electronic configuration of sodium and I want to know where is sodium placed in the periodic table. Now, without opening the periodic table, how can you convey what is the position of sodium in the periodic table? For that, we write the electronic configuration. In your schools, you must have written the electronic configuration as 281. This is how you write in your schools the electronic configuration of sodium. But now, since you have entered into higher standard, you can write the same electronic configuration in this form: 1s2, 2s2, 2p6 and 3s1. Now you must be wondering, how come? What is this? What I have written on the board? You know, this is the way you write the electronic configuration at the higher level. Now, after writing this electronic configuration, what does it convey to me? You know, looking at this, I can say this element sodium belongs to 3rd period. So the number indicates the period and the upper number indicate which group it belongs to. So this given element sodium belongs to 3rd period, 1st group, and S block element. It is S block element. So I know the position of the element by just writing this electronic configuration. But now the question is, sir, we write it in the form of 281. How to get this? Actually, this is the same thing. If you take this, this is your first orbit, which consists of two electrons. This together is called second orbit, which is 8, and this is your third orbit, which is 1. So the same electronic configuration which you have been writing in your lower standard, in the higher standard we write it in this form. Now how to get this? This is actually given by Of-Boy principle. Now what is this Of-Boy principle? Let me explain to you that. Of-Boy principle is called energy level, is the arrangement of S, P, D, F orbitals in the increasing order of energy level. Remember one very important point. You know, this S orbital can accommodate maximum 2 electrons, and the P orbitals can accommodate 6 electrons. The D can accommodate 10 electrons, and the F can accommodate 14 electrons. Now why is it like that? You will be learning later on in a topic called structure of atom in your 11th standard. Now let's see how we go for Of-Boy principle. For that you do one thing. You first write the numbers 1, 2, 3, 4, 5, 6 and 7 in this manner. After that, leave these two numbers and start with 2, 3, 4, 5, 6 and 7. Then leave these two, start with 3, 4, 5, 6, 7. Then leave these two, start with 4, 5, 6 and 7. So the first column you fill it with S block element. This is S. The first column will be S. Then the next column will be your P. The next column will be P. Then the next one will be D. And the last one will be F. So we have S, P, D and F. Now, after writing this, then you can follow this trend from the first orbital 1s, you move downwards and then go on following the arrow. Go on following this arrow. This is called energy level. Go on following the arrow and you will be able to write the electronic configuration of any given element, and you can predict the position of that element in the periodic table. Okay, so this is the order of it. From 1s come to 2s, then 2p, then 3s, 3p, 4s, 3d, 4p, 5s and so on and so forth. This is called energy level. Now, once you have written the energy level, now let us take the same example which I had given it for sodium. How to write the electronic configurations? Now we know that sodium's atomic number was 11 and mass number was 23. So total electrons in sodium was 11. So let us start writing the electronic configuration in this form. S, P, D and F. To begin with it, first you start with 1s. 1s. What did I say? S can accommodate only 2 electrons. So out of 11 electrons, 2 electrons will go in S. So out of 11 electrons, 2 electrons gone. Remaining will be 9 electrons. Now, next is 2s. Next is 2s. S again 2 electron gone. So out of 9, 2 electron gone. Remaining now 7. Now after 2s, it comes next 2p. So 2p. Now p can accommodate 6 electron maximum. So 6 electron gone, 1 remain. 6 electron gone, 1 remain. Now after 2p, next comes 3s. 3s. S can accommodate 2 electron, but we are left with only 1 electron. So you just write 1 here. So 1 minus 1, all the electrons are used up. Now no more electron is left. Now look at this. This is your electronic configuration for sodium. Now you can straight away make it out. The last number 3 indicates the period in which this element belongs to. So sodium belongs to 3rd period. And the number of electron on the top, this will indicate the group. So sodium belongs to 1st group. And which block? S block. And remember, S blocks are very strong metals. Very strong metals. Okay? So what is the position of sodium in the periodic table? It belongs to 3rd period. S block and 1st group. Okay, like that you can write the electronic configuration of any element. Say for example, an element X has atomic number 17. Has 17. I want to know what is the position of this element in the periodic table. So, I will start writing the electronic configuration. I have total 17 electrons. So, electrons are 17. Now start. The first orbital 1s will accommodate 2 electrons. So, 2 electrons gone from here. So, 15 will remain. Now the next is 2s. 2 electron gone more. So 13 electron remains. Now next is 2p. 6 electron can be accommodated in p. So 6 electron gone. So how much will remain? 7. Now the next is 3s. Can accommodate 2 electrons. Left out with 5. Now comes 3p. P can accommodate 6 electron, but we are left with only 5. So I will put 5 here. So 5 minus 5, 0. Now how will you know the position? Now remember, this 1 is the first orbit. These 2 are second orbit and this are third orbit. Looking at this, you can straight away say this tells you third period. So element X belongs to third period. This indicate P block. It belongs to P block, which is non-metal. Now the group, very important is the group. Now since it is the third orbit here, you need to add the electron. So 5 plus 2 gives you 7. So it is in the 7th group of Mendeleev. 7th group of Mendeleev. But if you talk in terms of Moseley's periodic table, the modern periodic table, then whenever the last electron comes in P, you need to add 10 to it. So when you add 10 to it, 10 plus 7 makes up 17. So according to Moseley, it belongs to group 17. And you know, group 17 is called halogen family. They are halogens. So group 17, 7th group of Mendeleev and 17th of Moseley's periodic table. So in this manner, you can write the electronic configuration of any element and know the position of that in the given periodic table. Okay? Great. So I believe all of you have understood the important part of writing the electronic configuration in this manner. Okay? And what you write in your lower standard was first orbit 2 electron, second 6 plus 2 8, and the last 5 plus 2 7. This is how you used to write in your lower standard. But now onwards you will write it in this manner and know the position of any given element in the periodic table. That will solve your lot of problems in that case. Okay? Bye everybody. Thank you for listening to me.